Um, Hello, welcome everyone for the week three of Associate Cloud Engineering journey. And yeah, firstly, it's a huge kudos to GDG Hallen for having such a wonderful platform and having that consistency and helping the community member to understand the certification journey. And yeah, so this is one of the key certification journey that we are driving if someone is joining for the newly to this particular call, make sure you see the recordings of the previous recordings of this particular certification drive, wherein we have talked about couple of things like how to get started with and what is cloud skill boost. We also saw a couple of things about IAM best practices and few more other concepts as part of this particular certification journey. Yeah, so what we are going to discuss today is, as part of this module, we are going to discuss mainly on planning and configuration. So when it comes to cloud solutions, planning and configurations play very important role, and this particular slides will cover some of the key concepts and also some of the questions that you can kind of diagnose where in terms of the Cyball fictitious company, which we had started with in our first session. So the module agenda is mainly split into like in this module we explore the scope of the task, and which is like mainly on the planning and configuring the Symbol Superstore cloud solutions, which corresponds to the section accordingly. So we'll be start discussing on some considerations for how you decide different kind of resources. Like when I say resources, it can be a compute resource or it can be a cloud storage resource, which is needed for the Symbol Superstore application requirement. So we're going to look at the requirement of what actually they need in terms of compute or in terms of storage, and we're going to see how best we can select a particular option for the particular requirement. So as I mentioned that we are going to see this as a diagnostic question with options, and we are also going to review them and also see some study plans. So that's what we are going to see today. So let's quickly jump to the next slide. So selecting resources for Symbol Superstore's cloud solutions. So, so the key points are planning and configuring compute resources. So, what is compute? So, as you all of you know, if you want to run an application or if you want to create host a database or create a data set, so you definitely need a compute resource which helps you to perform the particular task. Without compute or without the underlying storage, either you'll not be able to store the data or you'll not be able to compute or perform your required actions in your application. So compute plays a very important role. And in terms of Google Cloud, we have different options of compute. Like we have serverless compute options, we have containerized compute options, and we have the Linux based compute options, wherein it is like neither it's not a serverless or it is not a containerized, but it is a plain compute engine with operating system which you can configure and you can use it accordingly based on your customization. So there are different options, like as I mentioned, serverless and containerized and the compute engine. So it is necessary for any application whenever they are deciding or whenever they're moving to cloud, they need to understand which compute option is a better suit for them, and accordingly they need to take the step. So when it comes to data storage, um, Google has multiple data storage options, starting from the SQL databases or the relational database, and also the non-relational databases. And we also have things like BigQuery and couple of other options in terms of data storage. So we are going to see how we can better categorize them or decide them as well. And there is also something on networking that we are going to see. When I say networking, there are multiple things that come into networking. Whenever you want to talk to two systems, you need to have an IP address, and you need to have something called as firewall if you want to protect your system from the external vulnerabilities, or you need to have enable port if your application, if your server is running more than one application, you need to have a better port to map to the respective application. There are a couple of things like this. If you want to handle your application, or handle your system or a server in Google Cloud, networking is it's a key. So we are going to touch base on networking as well. So let's see, Symbol Superstore existing application. So e-commerce. So Symbol Superstore as an existing web application that provides an interface for customers to look at and order products. So the requirement is compute, container architecture, data relational backend, networking needs to be globally available, and need analytics capabilities to inform marketing efforts. So if you see, the requirement is they need a compute which has a container architecture. So for now, container, you just think like container is nothing but you're wrapping your application um, uh, along with your dependencies in a package which is easy for you, and it is lightweight and portable to be run across different machines without putting multiple effort, or without putting additional effort. So that is container in a nutshell. So then in terms of data, they need a relational backend, and which is relational in the sense it's a relational database that they're looking for, which is like has a set of rows and columns. And networking, their presence is global and they need to be globally available. There's another component, or the another subsystem called transportation management. So what they say, delivery service is becoming an important aspect of Symbol Superstore's customer interactions. Symbol Superstore would like to use Google service to keep track of truck location. So the requirement is dashboard of truck location in real time, analytics of truck mileage for preventive maintenance. Then we have the supply chain. As part of the Symbol Superstore has decided to migrate their legacy supply chain application to cloud. And so requirement is available local to their HQ, currently implemented in virtual machines with Linux operating system and a LAMP stack. So the other one is e-commerce requirement is the one which we saw is the same thing, compute with container architecture. And if you see the e-commerce cloud solution, what they're leading is like, here you can see what is the actual solution that you can see for their requirement. So if you see on the left hand side, where their requirement was to have a container architecture for their compute solution, and the container solution in Google Cloud is Google Kubernetes Engine, so which runs mainly on Kubernetes, and it is a managed service for Kubernetes which helps you to spin up your containerized application. So that's why they have been mapped to Google Kubernetes Engine. And in terms of relational backend, Cloud Spanner is one of the best option for you to handle the relational backend, and that's the reason why in Google Cloud we are choosing Cloud Spanner. And in terms of networking, the external HTTPS load balancer is one of the uh, option for you to externally host your application, expose your application, and it is a secure load balancer, and that's the reason why you see HTTPS. And then need analytical capabilities to inform marketing efforts. So when it comes to analytics, we have something called as BigQuery in Google Cloud, which helps you to query your rows and columns in a different way, wherein you can get better insights, business insights of your data. which is quite impossible with the relational database. And BigQuery really helps you in that aspect in order to query your data and get the business insights. Then Symbol Superstore's transportation management solution. So we also had the scenario where the transportation management had couple of requirements. So dashboard of truck location in near real time, and analysis of truck mileage for preventive maintenance. So this was their requirement. So what is the cloud solution for that? So PubSub is one of the option for you to enable messaging within your system. Let's say if you have email notification channel, and on the other end you have a scenario where your application has to notify PubSub channel. And if that is the case, if you configure PubSub, it is easy for PubSub to get notified on a topic whenever a particular topic is being called. And on the basis of that, you will be able to do further, call to your architecture based on what it been called by the PubSub topic. So here they need it to be very near to real time, and that's one of the reason why you see it's like PubSub is there. And in this case, compute is cloud run function. It is not containerized or the Google Kubernetes engine. The reason behind is like Google Kubernetes engine. It's like if you it's like I would say it's a managed service of Kubernetes, but if you are using Google Kubernetes engine, there is also additional I would say additional management task for you to handle the workloads, maintain the Kubernetes version, and you'll have to handle a lot of things within Kubernetes system. It is not just that you can straight away use the GKE. There are a lot of maintenance activity or the operational activities that you have to handle, but uh, the only advantage with that is you get more options to customize, and the maintenance is quite I would say like expensive. You need to handle the maintenance in terms of Kubernetes engine. But if you are a kind of a person who don't want a full-fledged Kubernetes platform, and you would want to give most of the thing to Google Cloud, and you just want to host your application, containerized application with just a Docker file, then Cloud Run Cloud Run function would be a better option. Uh, in terms of containerized application, Cloud Run will be good, wherein you have a Docker file and you just use the Docker file to run your containerized application. But in terms of Cloud Run function, you will be writing small functions. It can be in multiple languages. It can be in Go, or it can be in Python. There are multiple other languages supported by Google Cloud. For a lightweight function, you use this Cloud Run function as an option. And in terms of messaging system is one of the key system where Cloud Run function is one of the option. And behind the scene, Cloud Run function will also call Google's uh, cloud build, which helps to containerize this, which is not shown to the user, but behind the scene, whenever you write a Cloud Run function with a Go or with any of the supported language, Google internally containerizes it. But for the user, it's not a burden for them to take care. No need to have a Docker file or no need to have anything. They just need to write the plain function, and the Google Run function, earlier called as Google Cloud Function, will take care of it. And for orchestration, we have data flow, and for storage, Bigtable. We will see what all this what is Bigtable and couple of other things. And for networking, in this case, it's not global, and that's the reason we have regional as an option for networking. So next is supply chain. So Symbol Superstore has decided to migrate the legacy supply chain application to cloud. Requirement is available local to their headquarter. then currently implemented in virtual machines with the Linux operating system. So if you could see here the compute option is not cloud function or not Google Kubernetes engine. Instead, it is compute engine. So what is compute engine is like? Compute engine is like your on-premise. Let's think like a on-premise service, Linux system, a Red Hat system, or a Fedora system, physical Linux server. It's exactly you can think like that. It is in Google Cloud, if you want similar kind of a Linux server wherein you can, you know, play around with whatever operating system you need, either Debian or Fedora or any kind of operating system that are available, then Compute Engine is one of the right option, because here the requirement is not to have a containerized application, or it is not anything on real time system. So they need a compute wherein they want control, over the operating system. Okay, so that's the reason why we are choosing compute engine as a compute option here. Then for data, we are using Cloud SQL, which is a SQL database. And for networking, we are using internal to VPC for backing the database. We'll look at what is this in the next slides, upcoming slides. And it's again not global, it is regional. And the load balancer is external HTTP load balancer, HTTPS load balancer. So let's now look into some of the diagnostic questions and try to understand from there. And yeah, all these questions are there in the workbook, and also the slides will have that along with the explanation. So please take a look after the session as well. Yeah, so your study plan will also cover all these aspects, that we are discussing. So if you could see the planning and configuration, configuring the compute resource, planning and configuring data storage options, and also the network resources. So what we have here, planning and configuring compute resources. So considerations include selecting appropriate compute choices for a given workload, using spot VMs and custom machine types as appropriate. So now what we are going to see here is, we saw a lot of compute options, right? We saw compute engine, GKE, cloud run function. So these are some of the key compute options. There are many other compute options as well, like app engine and different options. So what they're trying to say here is, it's very, very important to select the appropriate compute choice. Even before implementation, you need to do the design analysis, and then you need to better fit the right compute option. And there is also something called as spot VMs, which is like preemptive VMs. If you are kind of having a workload which has to be scheduled on a particular time, and you don't want your server to be running all the time, and instead you want something that is very preemptive and spot VM for a given particular time, and that is also there, which helps you to reduce your cost, and you configure based on your workload, or your schedule, and that way it makes the cost much more less when compared to having the server all time running. So let's look at some diagnostic questions. So Symbol Superstore decides to migrate their supply chain application to Google Cloud. You need to configure specific operating system dependencies. So first is option A, implement an application using containers on Cloud Run, implement an application using code on App Engine, implement an application using containers on GKE, implement an application using virtual machines on Compute Engine. So we have already seen this. The answer is Compute Engine. The reason is they want a control on the operating system. If you see, you need to configure specific operating system dependencies. So they need to configure specific operating system dependencies, and that is possible only with the Compute Engine option, wherein you can select the operating system and the other dependencies around it. So that's one of the reason, and the the workload is not anything which is containerized, and they are not looking for any serverless options. And with all this, we can easily say compute engine would be the better choice for them. So infrastructure as a service. So what we have to understand here. So what is infrastructure as a service, or IaaS? So Google Compute Engine or virtual machines running in Google global data centers have multiple things. Like, one is they take care of the complete control, and one is like there are two things that you need to consider. So the scope which Google covers, and the things that are part of your scope. So that's the main thing. So let's say, in your in previous scenarios, where cloud was not an option, people used to procure servers, and they used to uh, have some plan. And if whatever they predicted, or if things changed over time, they have to either get rid of the server, or it is going to be a cost for them. So there was no option before cloud that they can rent something, or you know they can get rid of a server, if there is no requirement in future. But because of this problem, is w- cloud trying what cloud is trying to address is, in case in future if your workload is very less, and you want to knock off some of your servers, and you want to have less servers, you can easily auto scale them, because infrastructure is no more that is you are owning. It is a service that you are taking from the cloud provider. So that's what they're trying to say here. And the infrastructure as a service has multiple options that we saw, like compute engine, Google Kubernetes engine, and couple of other options. So there are different scenarios and use cases for each one of them. When you take Kubernetes engine, it is for the containerized workloads, and it is also used for hybrid applications. Like, there are a couple of other options in terms of hybrid. If your application is in on-prem and cloud, GK has a couple of other options to do that as well. In terms of compute engine, as we mentioned, it is like, if you have a requirement to have a very specific OS or configuration, and if your on-prem services is like running on Linux, and you want to just do a kind of a lift and shift to another Linux server just sitting in cloud, and that is a easiest option for you. And you can also use custom VM images, then to be able to move to cloud without writing your code. There are multiple options, and criteria that you use in order to select the system. So the thing that you need to keep in mind is infrastructure as a service is something that really helps us to get rid of the cost, even if you want to scale down. And even if you want to scale up based on your traffic, it is quite easy, and no need to have the infrastructure advanced. It's on that, like, on the go, like whenever you need, you can easily scale up. So next is platform as a service. So what is platform as a service? So let's say you have a infrastructure, and you want to develop a Java application. So in order to develop a Java application, or in order to create a website or a gaming platform, you need lot of other components, right? It's not just you just need a server. It's not just possible to just have the server and you do everything. You need to do a lot of other things which your application really needs. It can be a Java application or a Node.js application. So platform as a service is something that gives you that platform in order to build your website or your microservice along with the infrastructure. So in platform as a service, there are multiple options like App Engine, Cloud Run, Cloud Run functions, and all these three are also called as serverless. The reason they are called as serverless is, whenever there is no traffic, You can also scale them down to zero instances. That way, whenever there is no traffic, you will not be charged for your instances. There might be some minimum charges for the IP address or some other things which are very static. Doesn't really depend on the traffic. But unlike the compute engine or the GKE, here since it is serverless, you are paying only for what you are using in terms of your traffic. So just you need to keep in mind whenever it is coming to serverless, the options are like varies from App Engine, Cloud Run functions. Yeah. So let's see some questions on this. Symbol Superstore decides to pilot a cloud application for their point of sale system in the flagship store. You want to focus on code and develop your solution quickly, and you want your code to be portable. So if you could see here, the main key things that you need to highlight is you want to focus on code and develop your solution. So as I mentioned, to develop a web application, there might be a lot of other, packages or dependencies that it might be needing as part of the platform. But if you're spending more time on that, it will be difficult for you to spend time on coding or writing your application. So they are looking for something like where they have an support to develop their application with focus on coding, and it is also portable. So compute engine is one option that they have given, and package your code to a container image and post it to Cloud Run is the second option, then GKE and Cloud Run function. The option here is Cloud Run. The reason behind is, as I mentioned, Cloud Run gives you that platform as a service, and it is also one of the serverless option wherein you can host your containerized application. And that's the reason why they have, going with Cloud Run, and you can easily knock out compute engine because it doesn't provide you any kind of a platform or it is not a serverless. And similarly, GKE, and then for Cloud Run function, it is not going to be an option for Cloud Run function also, because Cloud Run function is mainly for a lightweight, I would say, system calls, sorry, a lightweight function, which will be used mainly in the kind of a messaging kind of a system. And it's very difficult for you to host a web application or a heavy application on Cloud Run function, and it is not feasible as well. So the question is, let's look at what this one says. An application running on a highly customized version of Ubuntu needs to be migrated to Google Cloud. You need to do this in least amount of time with minimal code changes. Create compute engine virtual machines and migrate the app to that infrastructure. Deploy the existing application to App Engine, deploy your application in a container image to Cloud Run, implement Kubernetes cluster and create pod to enable your apps. So the reason why we are going with compute engine here is highly customized version of Ubuntu needs to be migrated. So when it comes to operating system, as we saw, we if you need control over operating system, then compute engine is one of the option, and you need to do this in least amount of time with minimal code changes. So that's one of the reason, and the other options are ruled out because you need control on your selecting your operating system. So let's look at the next question. You want to deploy a microservice application, you need full control of how you manage containers reliability and auto scaling, but don't want or need to manage the control plane. So what they're saying here about control plane is like, in terms of control plane, you think like as a master. Master is also master server or control plane. It's more or less the same, and they want a microservice application with full control on how to manage the containers reliability and auto scaling. The key points that you need to highlight is they want to manage the containers reliability, and also they want to manage auto scaling, but don't want or need to manage the control plane. So if you see, when it comes to container, and if you want to take full control on your containers or auto scaling or reliability, Google Kubernetes Engine is one of the option. And if you also want to, there are two options in Google Kubernetes Engine. One is like you go with autopilot mode or you go with standard mode. So we will look into that more deeply whenever we get into that use cases. But as of now, you just think about GKE is like containerized solution for you if you're looking for any containerized solution in Google Cloud. Yeah, so here what you need to see here is all those things that we discussed in the slides. They are very much thoroughly covered in these modules and in these courses and also in the skill badge. So pay attention whenever you are covering these modules. It will mainly cover all the concepts that we discuss now on selecting the compute engine and selecting the right virtual machines or the platform as a service. So you can easily understand, and also the networking services which we will be discussing in the further slides will also be mainly covered in these things. And also make sure you follow the documentation as well, specific to these topics. So yeah, next is planning and configuring data storage options. So the data storage options are, there are many, as I told you. So Saeed, my colleague, will be covering a lot of options as part of the future slides. But just to give you a gist about what are the options we have Cloud SQL, BigQuery, Firestore, Spanner, Bigtable as part of the data storage options. And yeah, so options depend again like on different types, like whether you need global or zonal or regional, and couple of other concepts are there, like what kind of storage class you need, whether you how long you need to store data in your storage. Let's say you wanted to store for more than a year. There are different classes in Google Cloud storage bucket, wherein they call it as storage classes. They have like standard, nearline, cold line, and archive. Each of them correspond to a particular period of time where they can hold the data. So we will be discussing those things in the futures, in the further slides. And yeah, would be passing you to Saeed to carry on further.
All right, thank you very much. Hello,
Thank you.
everyone. Let me share my screen.
Sure.
Um, can you able to see my screen?
Yeah, yes, Saeed, be able to see your screen.
Okay. So we have, as my colleague says, hello everyone. My name is Adewumi Saheed. Today we are going to talk about planning and configuration data storage option. So this section is about picking the right option as a cloud engineer and to make your right choice anytime you are setting up your infrastructure. So we are focusing on the data storage option, whereby we have different uh, products available for the storage. We have Cloud SQL, BigQuery, Firestore, Spanner, and Bigtable. And if you are choosing your storage, we have the Zona President, Bina, standard, and nearly Cloudline and archive data storage type. So I will be diving in to give more explanation. So yeah, we have a question to like cyber Simba's superstore need to analyze whether the mid quarter sales projection assigned to run this query are familiar with SQL. So this question is talking about an is Simba store need analysis tools for their SQL, and the best option here is BigQuery because BigQuery is used for analysis of data, and here yeah we have it. And as a cloud engineer, we use BigQuery to analyze the SQL data. You can see we have two other options. We have Cloud SQL, Spanner, and Firestore. Cloud SQL is to use for set up a database for SQL, while Spanner is as for SQL too, but is in for a big project or an enterprise project. And Firestore is used for no SQL. So the best option here is the BigQuery for analysis of SQL data. So here we have the comparison of comparing the data storage and database options. We have different type of database. We have relational, we have non-relational, we have object, we have warehouse. So if I'm talking about relational database, they are the type of SQL, Postgre, uh, relational database. For non-SQL, we have Firestore, we have Bigtable. And for the object, we have cloud storage, whereby we store like anything related to images, file, any type of document you store it on cloud storage. And the warehouse, we have it for uh, analytic purpose. So yeah, for the clouds, we have they have it in a group format whereby for the cloud SQL, we have it for the web framework whereby you can use it for link it with your application for fetching of data. A good example for e-commerce. For the spanner data is used for a huge amount of data. I mean, data we have so we have something called it. So whenever you are choosing as a cloud engineer, you have to be considering the number of users or the number of data you are using your database for. So before you choose, in this situation, this spanner is used for a huge amount of data compared to SQL. Although Google Cloud have the ability to scale up your database as you configure. So that's the difference between the Cloud SQL and a spanner for the relational database. Now, for non-relational database, we have Firestore. Firestore is popularly known. If you are familiar with one, they have a database there we call Firestore. So Firestore is used for uh, like a gaming, like document data. The data needs structure, so we can call it unstructured data. We use it for mobile and web or hierarchy data. So we have big table. Big table is like compared to spanner, big for but on big table for are used for unstructured data like SQL, unlike spanner data. So they are used for huge heavy amount of data. So for read and write. So we have cloud storage too, for storing of the different form of type, the backup file, images, video. You use cloud storage for it. For BigQuery, we use for analysis of data. So let's say you are some data scientists need some data for analysis. You can move it or back it up on a BigQuery, and they can use it for analysis. So it's not only used for only cloud engineering alone. The cloud data science, data engineer use warehouse for their operation. So moving forward, yeah, we have. So before we answer this question, we have the different type of data we store. We have data type, and it's based on the accessibility. So if you are accessing the data frequently, we use standard data set, data type to save to configure it. For uh, linear 9 is between 30 days assessment for the accessible for the users within 30 days. So code line we have 90 days, and this we have it like anytime you want to use it once in a year. So this is different. All these are used for the same purpose, but based on the accessibility for the users. So the advantage of this is to save you a cost. Maybe you are backing up your data, you are not using it frequently, you can put it on archive, or maybe once in a while you can put it on code line. So it's based on availability. So here we have Simba Superstore supply chain application frequently analyze large amount of data to inform business processing and operational dashboard. So this they want to be using frequently for analyze large amounts of data. So this type we have to use standard because frequently user expects to have access to it as this implies frequently. So if you are accessing the data frequently, you are expect to set up standard data class. So moving forward, we have a storage class. So as I've said earlier, we have the standard, we have layer 9, we have code line and archive. So this no retrieve cost, cost implication. We have no retrieve cost, no minimum storage duration. So this is type of hot data, meaning anytime you have access to it, you get it instantly because of they have no latency compared to linear 9, whereby we have 30 days minimum storage. So any data you store that you are not accessing within 30 days, you can put it in this category. Same thing for the code line, whereby any data you are storing uh, within 90 days, you are keeping it in this storage set class. And we have archive, anything we want have over a year, you can keep it here. So the accessibility depends on the cost. So you see this is very low cost, this is more even lower, and this is the lowest. So if you are storing your data, you have to choose the classes of uh based on how you want the user to be accessing the data. So and this is used archive mostly used for the data archive or data recovery, just for a backup, saving of backup in order to save you the cost. So moving forward, uh, the superstore, Simba Superstore has a need to populate visual data dashboard with historical time-based data. This is an analytical use case. So yeah, we are talking about they want to use the analytic for the analysis of data time based. So they have different options here, but I think the best option should be A and E. So because here we have BigQuery for analysis of data, and it was mentioned that it will be using for analytic use case and history time based. So big data, because they are not this big table is for NoSQL, meaning it can be used for read time. Most of big table data are used for read time uh, information. So these are the best two options for the BigQuery. Cloud storage is used for storing files, not data. Uh, that's the basic difference. That is why the cloud storage is not a big good option. We have Firestore. Firestore, it's used for uh, it's used for NoSQL, but it's not does not support heavy data in real time compared to big table. And as a cloud engineer, you choose the best option. Cloud SQL is a SQL query which can it will not be effective for time-based data. So these are the two keywords here: time-based data and analytical use case. So moving forward, we have comparing storage option use case. So we have in the right hand side, we have in the left hand side, we have type for and use case, and we have each tab. So let us go for the type. We have NoSQL documents. For the big table, we have NoSQL white column. Uh, this difference they are in category. If we can remember earlier, we talked about the relational and non-relational. So these are one category. And for the cloud storage, we have Boom Store. For the Cloud SQL, we have for the SQL, we have Cloud SQL, we have Spanner, we have BigQuery. So this for the best for Firestore is best for use for storing, synchronizing, and query data, whereby Bigtable used for flat, heavy read and write analytic data. And if you can remember, that's why we pick big data here because of the time-based data. So coming back here, for analytic data, this for the big table. For the class storage, we have structured and unstructured data, meaning we are uploading something like images, picture, videos. We use class storage to store that. For SQL, we use it for relational database or structured data like column and row, whereby we have a web brim application, like we are building a school portal or any related web application. For Spanner, we use it more of like SQL, but it's for bigger. It has more capacity compared to Cloud SQL. So, and same for the BigQuery. BigQuery is SQL, but it's used for analysis of data, analytics of data. So the use case here, we use Firestore for mobile web and server development. Mostly we use this use case for Firestore. Most of the time we can use Firestore through using Firebase platform. So for the big table, we use this for finance, IoT data like Agric platform. You can use big table for that. For Cloud SQL, I've said it earlier, we talked about images, large media files, and backups. And for the cloud SQL, we use it for normal like an e-commerce platform whereby user can use their username and password, customer and others. So for Spanner, uh, you can see here we use it for same use case of Cloud SQL, but in global consistency. We have to consider availability or the number of these can process millions of data at once without any issue compared to Cloud SQL. Cloud SQL may have faced some challenges of latency compared to Spanner. So I think that is the major difference between the Cloud SQL and Spanner. So for the big queries used for analysis of data, so which is our data warehouse, basically for data warehouse. And here we have these different resources you can use for planning and configure your data. And here we have a setup. I think after we can practice this at our own pressure time, leisure time. Moving forward, we have uh, planning and configuration of network resources, which involve the load balancing, availability of resources, location in the network, and network service here. So here we have uh, a use case whereby Simba Superstore is plotting an update to its e-commerce app for the flagship store in Millipion, Minnesota. The application is implemented as a tiered web service with traffic originating from the local area and resources dedicated for it in USA Central 1. You need to configure and source low-cost network but load balancing. So here we are talking about network and load balancing. Load balancing is as it sounds is how to can user can able to have access to the your infrastructure without any issue and make sure it is very secure. Here we have the uh, option C. So we have different options here, but we have implementing a premium tier global external application load balancer connected to the web tier as the front. So this idea, okay, before I go, I think let us approach this before coming back to solve this. So here we have type of load balancing. The load balancing is more of like anytime you set up your infrastructure and someone is trying to access it, you have to some people access it from different region or different same zones, different region, part of the world. So as a cloud engineer, you have to set up in order to give easy accessibility and to avoid low latency to your application. So we have two type of load balancer. We have application load balancer and we have network load balancer. And we have external and internal. So for the application load balancer, we have external, internal, and for the external, we have global and regional. For internal, we have regional and cross-regional. So this, like let's say, this is based on the continent to country. So here we have global external application load balancer, and we have regional external application load balancer. Same too for the internal. Internal is just like the the difference between global and regional is the time. Like if I'm here in Africa, I'm trying to access US, the latency to be quite different if I'm within Africa country. So that is the difference here. So as a cloud engineer, you have to configure in such a way to be very easy. You have to choose the nearest platform. Although Google has provided other infrastructure to make user can able to access your infrastructure without any delay, and some of the product are CDN, content delivery network, whereby you can load your data or information faster compared to doing it using a long latency, using high latency for your application. So here we have the network low latency, we have proxy pass through. So and as we have external, internal, and all this is still same configuration. So we have global and regional, we have regional and cross region. So for the internal, we always have cross regional and cross region. For external, we have regional and regional region. So this, they are, whenever you are trying for this concept, we are trying to set up an e-commerce in particular location, and the application is implemented as three-tier web service, which traffic is originated from local area and the resources dedicated for. So they are using the resources from the local area and they are connecting to the user central. So the solution here says that configure a standard tier regional external application load balancer connected to the web tier as a front end and regional internal load balancer between the web and the backend. What they are saying here is that they are trying to we are trying to connect our application load balancer with the web as a front end and a regional internal application load balancer between the web backend. So they are using a load balancer to connect the front end and backend for the to reduce the latency. So moving forward, here we have some questions says, what Google Cloud Load Balance option run layer 7 or TCP? So for people that are familiar with networking platform or networking, one of the basic rule of our cloud platform is networking. So we have computing engine, we have storage, we have data, and we have networking. So this part focus more of networking, whereby you can know the difference of the network responsible for fast loading of application, and the second one's dealing with network. So here we have a global network application we have global application load balancer, and these are the resources that are responsible. We can go through it, maybe after we can do little lab and see how we can able to set up our virtual machine and connect with the network. So here we have our knowledge check. Which storage class is designed for long time storage as 360 day minimum storage agreement and low storage price as compared to other storage type? You can see, if you remember when we are doing this, we have uh, we have, if you can remember this part, whereby they are talking about the storage time, the minimum storage duration. So we have 365-day minimum, which is the solution should be archive. Here we have um archive. So this definitely should have to be archive 365. So it's almost a year. So yeah, the solution is archive. So moving forward, which serverless option is based on developing and executing small snippets of code? So yeah, it should be I think we didn't it should be serverless. So this is the cloud run function. So it's developing and execute small snippets code serverless. So if you are talking about serverless is more of like server management. So if you are saying serverless, it does not mean that you are not going to be using server, meaning you don't have to be worried about managing your server. So, and using this, you can choose between option A and option B. So in case you are in exam or you are in an exam for ACE certification exam, what you will always do is to pick the nearest option, then use the terms to compare the one that is close. C and D is always concerned about data analysis. I mean, data flow is for data and BigQuery is for data. So the serverless should be between the cloud run and cloud function. So for the smallest snippet, I will go for cloud function. So cloud run function is the smallest. For, let's say, for instance, you are just an event application, you just run it on cloud function. So most of the time, uh, it is very easy because you can connect with your third-party platform like a GitHub, or you can just upload your code and it will just be running. So it says serverless option based on developing small snippet of code. So it's the best option. So in some scenario, you can pick Cloud Run, but because of the small snippet of code, you can go for Cloud Function. And also Cloud Run is for serverless, a serverless option too, but because of the small snippet of code. So I think we are end of today. So uh, let me do the basic lab. I mean, how we can set up our cloud storage for people that are still try to set up uh, relate with the cloud storage. Let me share my screen for my class for the lab. Okay, can you able to see my lab? Are you able to see my screen?
Yes, yes, everything is perfect.
Okay, thank you. So this is introduction to Cloud SQL for BigQuery and Cloud setup of SQL for BigQuery and Cloud SQL. So SQL introduction to the SQL. We have structured query language. It's a programming language for query of data and data sets. So here we are going to set it up on Google Cloud, and we can able to what we will learn and reading data into BigQuery and executing a simple query. So what we want to do, we want to migrate our data from SQL and move it to BigQuery for analysis, export a subset of data into a CSV file like Excel spreadsheet, and store the file in a cloud storage bucket, create a new SQL instance, load exported CSV as a new table. So what we are trying to do, we are creating a new SQL and load our file we exported, load it on our DB. So this is more of like a migration of data. So this use case is really perfect for setting up existing projects, existing file, and migrate to the cloud manually. So yeah, before we get started, we have some tasks here. We have five tasks. Five tasks says create a storage bucket, upload the file to the cloud storage, create a class SQL instance, create a database. Um, the first requirement says I should just as usual, we are expected to start our lab. Click a lab. So click on start, use the password for the people that are currently, but for the recording purpose, you can just check it later. So we have tax one, say the basic of SQL. So here we are talking about the basic of SQL. They are talking about the basic of SQL. SQL allow you to get information from structured data set. So structured data set, we have it like, can you see, we have the role, column and row. The role is for the title of the label. Like we have users, which is San and Rocky, and we have the price $35 or $50 shipped, yes or no. So this is the role. This is the structured data, because you can see it's all structured. You can able to even decode what this table means. So for unstructured data, an example of structured data would be an image file. So I think I've explained it in my presentation earlier. So and we have two keywords. So, so we have some keywords that's used in SQL, although you don't have to really know about it now, but if we can check out some crash course about SQL, you may know better. So we have select. Select just as sound to select data. We have from. So just like we want to select from, so we want to select from the table name. So this most of the time, this if you are familiar with SQL, these are the syntax, we call it syntax, or keyword that we use to communicate with database as a cloud engineer or as a uh, as a data scientist or data engineer. So here we have select users. So here is select users. So users is the column name, whereby you can see we have users here from what this from a sample table. So this table name a sample table. So this he has to fetch the all the users. So the response supposed to be all the users. So if you are fetching, we have another scenario here whereby you are fetching users and shipped. So you are selecting these two table. So there's another one we have where is a keyword to filter the table on a specific column. So select user from a sample table, which is this table where shape is equal to yes. So if you can check this table, we have yes, 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 yes. So we have like 4 years, and that is the selected data. So this is just like a simple query we use to communicate with our database, with our structured database. And yeah, so let's start now. This is going to be short. It's going to be quick one. Okay, so we open. I want to access my console. Okay, so I'm trying to log in. So I'm copying the username. Oh, okay, that's strange. Password. Okay, so I have access. So I have successfully accessed my console. So yeah, we have the tax one. So I've drawn the theoretical part of this. So we are not yet to do anything yet. A keyword. So we have test our understanding of a keyword that specifies the feed, the column value. So this is supposed to be this filter the table value, specific column value. So we have where a keyword that specifically feed column. Oh, select. Oh, okay. So column value select for the table data set uh, specific uh, specific what table of or table to pull from. So from is the keyword. Okay, so allow us to filter table for specific column. So I think this is what I made a mistake earlier. So this, and they are just trying to try our understanding. So yeah, we are talking about the BigQuery here. So we are told to explore the BigQuery console. So this BigQuery, if you want to access the BigQuery, you come to navigation side, click on find look at BigQuery sidebar, click on it. So this is the BigQuery. So BigQuery is majorly used for analytics of your data, your SQL, your project. You can use SQL data to run your BigQuery. So yeah, we have, okay, so I've done this. So yeah, good. So we are given a task here. A task is to explore the, so here we have in this section, you pull in public data into your project so you can practice and run. So it said, they asked me to click on add button. So we have add data. We are trying to add data on our project. So add data. Okay. So choose a star project by name, BigQuery. Okay. Come in. So Big Story Studio. Okay. So I want to get the data. I want to try to get data here for public BigQuery. Coming. Public data sets. So Google has some data sets available that we can use for our project. The project name, um, um, okay. So we are told to um, coming choose the star project by name. I'm expecting to see a data set something like this. Okay. This is not in line. Hold on. Um, no. Mr. Santos, are you there? I think there's an issue with the lab. I'm expecting to have some imported data that we can use for the. Oops. I think there is an issue with the there's an issue with the lab. I'm expecting there should be a default BigQuery data that we will use like more of like this. Uh, so and the BigQuery is missing here. So maybe there's an issue. Okay, I think this we can proceed with this since we don't have the BigQuery. So most of the time, if you are doing your lab and you have this type of challenge, right, you can click on this top hand side, and at times you can find the customer support, and you can reach out to the customer support and they can able to fix it for you. Some of the time there is a system error, just like what we have today, because by default we're supposed to have our export BigQuery public data, and we can export it and do whatsoever, like the next task, we can perform the next task with it. But right now, it's missing, so I don't know why. And I've been suspecting when we're trying to log in and without password and to log me in. Or am I using wrong? Am I using wrong account? It's the same account. Oh. So yeah, maybe I will have a recording section. I will try and check it again. I have a recording section and I'll share with you before the next section. Yeah, thank you. Hello?
Okay, so it seems that this brings us to the end of today's sessions. But one thing I'd like asking you to share links to
Okay,
necessary
okay.
sources and labs you want that attendees finish till the next during the next week before our next session. So, okay, this session was recorded. I will stop recording.